Hey manufacturing world, welcome to another episode of Shop Matters, sponsored by Okuma America. I'm your host Wade Anderson here in the studios in Charlotte, North Carolina, and today I'm joined by two Okuma application engineers. We've got Chris Davala and Ron Raniszewski. Chris, tell us a little bit about yourself.
Sure, my name is Chris Davala. I'm a principal engineer for Okuma. I've been with Okuma for about 5 years, I guess, total. A little bit of background. I've never really had a job as a paper boy or in a McDonald's or anything like that. I fell into a machine shop job when I was about 15. Just kind of fell in love with the industry. Been programming, setup, machinist ever since. So this is kind of like going to the toy store every day for work. You get all the new fun toys to play with. So it's perfect.
Yeah, excellent. Ron, how about you?
I started at Okuma October 88 in our manufacturing, worked there for 9 years, went to our training department, and then been in the A group since 2000.
Okay.
Now I'm the supervisor of the machine center group, so I get to work with Chris every day, so it's not too bad.
All right. So
Should make your day.
You're the top guy on all the mill
No,
guys?
not at all. I just get to work with the top guys.
You're the guru that knows all.
Not at all. Just get to deal with it all.
Yeah, I hear you. Excellent. So, Chris, what's your kind of go-to style machine? Are you more of a turning guy, more of a milling guy? What are you most comfortable with?
At Okuma, I've spent more time in the turning world. Prior to Okuma, probably more time in the milling world. But if I had to pick my favorite toy, I think the Multus for sure. It's a little bit frustrating at times, but a mill turn is hard to beat. It's super versatile, and it's just a lot of fun to see what it can do.
Okay. And Ron, how about you? How did you get started in this industry?
When I was in high school, went to a technical high school, and basically my dad was a toolmaker. So his buddy had a shop, and like Chris said, he was 14. I was 14 and worked for my dad's buddy for a few years. And then just different places, different times, doing different things. Manual, CNC, well, NC at the time. Mm-hmm. So it ain't changed. It's just different.
Right. Yep. So today we're going to kind of peel the layers on top OSP functions or features of the control that a lot of people don't use or underutilize. So I'll share a story from my perspective. I went to Japan. It's been probably 4 years ago. We did what we call our OAC days, Okuma America days, where we take a group of customers over to all the different manufacturing facilities for Okuma. And they start out with doing a little introduction. The Japanese provide a little PowerPoint presentation and give you an overview of the company. And I did a little presentation on technology and basically kind of along these same talking points of things that you should know about your Okuma controls or Okuma machines that maybe you don't know. So I stood up in front of everybody. We had about 30 different companies, about 60, 70 people in the room. And I asked how many people here in the room own Okuma lathes. And about 90% of the room raised their hands up. And I said, how many people know and utilize Harmonic spindle speed control? And every hand in the room went down. 100% of the customers that we had that were Okuma users, none of them use or even knew what Harmonic spindle speed control is. So I gave a little background on it. But instead of me talking, I'm going to turn it over to you, Chris. Why don't you talk a little bit about Harmonic spindle speed control? Most importantly, what does it do for the customer? Where would he want to implement it?
Sure. So Harmonic spindle speed control has been on Okuma lathes for probably 30 plus years, right? A lot of people don't even know it exists. So what it does, as you're machining your part in a lathe, the old school way to remove chatter is to turn the knob to speed the spindle up or slow it down to just kind of reduce that constant harmonic. So what Harmonic spindle speed does for you is it will move your spindle speed up and down by a given percentage based on parameters that you tell it, and over whatever you want for a time constant, right? So it's always fluctuating the RPM, so that way you don't build that constant harmonic that induces chatter. So people have done it forever, right? Just turn the knob and make it go away, but now you have a way to do it for you automatically, so you can put that right into your program. But there's a lot of people that don't even realize it's there that could be taking advantage of this stuff. So kind of like I I compare it a lot to a cell phone, right? You look at your cell phone and it's originally made for making phone calls, right? But most people, I would say, make phone calls 10% of the time with their cell phone.
Right.
So if you look at the machine tool the same way, it's actually made for making parts, but there's a lot of other stuff that it can do that people just don't always take advantage of.
Okay. So if I was a setup guy, setting up a part on a machine, how do I utilize it? How do I program it? What do I do to fire that function?
Sure. So it's a G code that you'll use to fire it. There's 3 different parameters. So you'll have a parameter for your percentage of change. So for example, if you had a RPM of 1,000 RPM and you wanted a 20% change, it'll swing between 800 and 1,200. You give it a time value. So how long does it take to get from 800 to 1,200? So maybe 2 seconds. And then there's a dwell value. So if you want it to sit at either end for 0.2 of a second or a second or something like that, you can have the ability to do that as well.
Are there applications where you would not want to utilize it?
Absolutely. So something like drilling or threading, right? You need a constant RPM to do that stuff because fluctuating is not going to be very helpful. So something like that, you definitely do not probably want to use it.
Okay. So Ron, I'm going to ask you one of my favorite topics right now with especially the rollout of the new horizontal, the MB5000H Mark II series. Cycle time reduction was a big part of the design and implementation of that machine, and that feature is going across the board on the horizontals. Talk me through a little bit of that. What is cycle time reduction? And again, from a customer's perspective, how does he utilize it, and what's that going to do for him?
Okay, the whole MB new design, it's the structure of the machine's been changed to get things into position faster. ATC shutter door's different. But the cycle time reduction function we've had for, as Chris said, a long time. But now Okuma's made it a little bit easier to use where we have some screens where you can pick and choose what you want it to do, how you want it to do it. Like we can move the tool change position dynamically on the fly. We can make the B-axis not clamp if you're using smaller tools. Instead of me having to change my program, I modify this parameter so when it indexes, it ignores the clamp, so it's a little bit faster point to point. Cycle time reduction for the spindle. Instead of waiting to get up to 15,000 RPMs, it just takes off immediately and gets to the point faster than it used to be waiting. So they've incorporated just more man-readable screens that makes it, again, just easier for you to use.
Now, is that something you turn on and off through G or an M code in the part program, or is it constant on? You're just setting parameters?
It's a setting that you name your program to new version, where it's associated with this part program. You would call up the program and it automatically brings in the cycle time reduction things that you want to do on this part. And the other part you can change. Again, you maybe not want to move the spindle before it reaches RPM or some other features, so we can tailor it per part program without having to edit the program.
Okay.
It's basically like calling a sub-program
right
from your main program that has all your cycle time reduction settings in it, essentially.
Okay. So if I'm setting it up to do a very light part where I want to do, maybe I'm doing a bolt hole drilling pattern, I want to dial in my movements from hole to hole, I can dial that parameter set up that would be linked to that part program.
Yeah, so next time when you run it runs that one all the time, so you're not really having to redo it. So you can save that file. All so it makes it easier. The old days we had to put M codes in the program, tweak it. Now it's more visual. You see what it's going to do. There's a nice graphical interface that makes it a little bit easier to understand.
Okay, excellent.
It's nice.
Yeah. You can also call multiples too, right? So if you want to have a setting for your bolt hole circle that you're doing and you want it to set a certain way, but then you want to speed up other things later in the program, you just call a different sub program essentially, and you can have multiple cycle time reduction settings in the same program. So it's pretty handy.
All right, excellent. With IMTS coming up on us, obviously you guys, I know everybody in your teams are wide open getting IMTS demos put together and trying to get ready for the show. I know it's a huge undertaking for you. One of the big themes or focuses for Okuma this year for IMTS is going to be the automation side of things. Yep. So we're going to have some new technologies that's going to be out, the Armroid, Standroid automation units that's going to be on M560s, LB3000s, Genos lathes. But along with that, I'm not going to go too deep on the Armroid side yet, but I know one of the components that is required for that, because it basically uses AI to program itself, it runs off collision avoidance software. So collision avoidance software is something we've had for how many years?
2006.
06?
Going back a ways.
I remember we took a Multus to IMTS probably around 06, maybe 08. With the joystick, we had all the sheet metal off the machine and gave people a joystick to try to crash the machine. So it's been around quite a while, but how many people do you think are utilizing it?
And I'd guess probably 10% of the people that have it actually utilize it. So it takes a little bit of time to set up, right? So people don't feel like they want to spend the time to set it up properly. But once you have it set up, I mean, it's a security blanket for sure. If you look at people in the industry today, they use a lot of products like Vericut, right, where they have a digital twin, so they want to prove out and make sure there's no crashes or collisions before they start the machining process, which is great. So make sure that your code is good. But when your operator puts it in manual mode or throws it in MDI or something like that, so now you're kind of flying blind and then making assumptions that he's not going to make a mistake and hit something. A lot of these machines are really expensive, right, with really expensive parts, expensive tooling inside them. So collision avoidance is basically an onboard simulation software, if you will, for any machine movement that's going to happen. So if you people consider the time it takes to set it up, but they rarely consider the time it takes when your machine's down because you wreck the spindle.
Right.
So
okay. So what all is involved in setting it up?
So the machine components themselves, right, are always there and always active. So Okuma sets that up from the factory. So the machine will never physically run into itself, assuming it's all set up correctly. The user would then set up if it's a lathe, they'd set up their chuck jaws, their workpiece. Machining center, you'd put in your vise or whatever else you have. You define your tooling, so your tool holders, your cutting tools, all that stuff. And then once you load that tool into the spindle, right, the collision avoidance software shows that in there. And then you set some parameters on how close you want to be able to come to things. So do you want your interference distance to be 5 millimeters or 5 inches? And when you're trying to get close to those items, that's exactly how far away it's going to get when it stops. Okay. During the program, it looks from the read ahead point. So if you have a problem 1,000 lines ahead or whatever the number is, it's going to stop well before it ever gets to that motion. So you're very well protected then.
Okay. Ron, what are the advantages from a mill standpoint do you see with collision avoidance? And think of it from 3-axis, 4-axis horizontal to 5-axis.
Well, like Chris said, the higher tech machines, you need to protect yourself because with the trunnions being able to move 120 degrees one way, 90 the other way, so with 210, so you could potentially have it spun up and crash right into the side of it by accident because you're not paying attention to what you're doing. And just like he said, the parts also, I mean, $30,000, $40,000 isn't uncommon to have a workpiece that you just crashed into the side of it because you weren't paying attention. From a tooling side, it protects your investment on your holders, your spindles. I mean, if it's not running, it's not making anybody any money. So the setup time, it is long at the beginning, but each time you do it, you get better and better at it. So it's just, you have to understand that you got to give a little to get a lot.
Right.
So that's the big thing that people need to understand.
Yeah. Will it run in 5-axis mode? How do you go about, I saw a demo that you did recently at one of our open houses showing a 5-axis part and setup and how it functions.
In the 5-axis mode, we have to import the finished part, but it protects it on the approaches. It won't crash into the part. So that's one of the things that you have to do. You have to kind of manipulate the data due to the fact that with the collision avoidance, the super nerves, the computing power, we don't want to sacrifice too much. So if you import the finished part, now you won't have the devastating crashes. You may break a tool, but you won't have anything going through the side of the fixture completely into the part.
So in the current control setup, will it cut off automatically if you're in TCPC mode?
Yeah, so you don't have to turn it off. It knows when it gets to that line of code, it shuts it off. And usually you'll have your big wrecks when you're approaching and when you're exiting. So a GO, it won't be, it'll be protected, I should say.
Okay.
So it makes it a little bit easier for you in that regard. You don't have to turn it on, turn it off.
All right. What about, as we're talking about the 5-axis platform, and I'm assuming this is going to be the same on a Multus platform, but 5-axis auto tuning, where does that come into play? When would a customer use it, and what's it going to do for you?
I mean, from the mill side, we've been using it, I don't know, 10 years probably now. And it just helps you long term. The machine's going to move a little bit over time on the foundation, twist and bend and weather changes. So it just ensures the accuracy. The pivot is set at the factory, and when we auto tune it, it goes around. And if you've seen the videos, it can be 10 touches or 30 touches, and it moves the trunnion and A and C and all the axes. So long term, it just keeps the machine's error to a minimum. It's not going to fix 2,000s, 10,000s error. If it's twisted up, first we got to make sure it's installed right.
Now, I'm going to assume everybody knows this term, but just in case, when you talk about pivots, what is a pivot point on a 5-axis machine?
Well, it's not really, well, it's a point in space, but it's the mechanical variations from where the two rotaries come together. So when we talk about the center of A, it's the part that flips sideways on the MU, and the center of C, so there's a little error. From a manufacturing standpoint, nothing's ever perfect. So we need to know where it is. We calculate it, and then we auto-tune it to that point, and basically the better you have your pivots, the auto-tuning has little smaller errors that it finds. So it makes it just a little bit easier for you to use it.
Okay.
The nice thing about it, right, you've always been able to go in and manually change your pivots and do all these things, but it takes a lot of time to go in, probe the trunnion in different spots, put a tooling ball on there, manually walk around, do the calculations, all that stuff we used to do with macros all the time. But now this just takes all the guesswork out of it, right? It makes it super simple. You put on your tooling ball, you bring your probe over top of it, and you push go. And it does all the stuff for you. Once all that stuff's turned on, right, it's active in manual and in auto mode. So your discrepancies in your machine geometries, right, even if you're manually just going to cut apart or walk over and jog it over and drill a hole or whatever, it still also has the same accuracy level because it's still always active.
Okay. Then there's a quick check setting, right? So you can go in and do kind of a short run version of it, then a long run version. What does that look like? What does that entail?
The quick check, I mean, we use it more for just, you can use it to warm up the machine, or you just check the ball different places and almost to verify the accuracy of the machine. Did anybody hit something? Or is it just, did it move? Is the floor bad?
So the proverbial second shift guy must have done something.
Exactly.
You know, you can go in, check
You know
it.
him too, huh?
Yeah, I think I was him once or twice.
Everything bad happens on night shift, right?
Yeah.
So you can just take a quick 5 minutes in the morning, assuming your fixture and stuff's not in the way, run your auto-tuning program real quick, and then just at least have a good level of confidence going into your shift or the part that you're getting ready to make to know that the machine geometries are where they need to be.
And you can store that value too for different workpieces and different weights. We've had it where heavy workpiece, the trunnion and the geometries, it doesn't change, but the weight, there's a little bit of a moment. So we can check it with that weight. And if you run that part again, you can call up that auto tuning and run it, and that way you have it stored so you don't have to do it continuously.
Okay. So weight, you keep leading me right down certain paths here. So as you're talking about weight on machines, I know there's a function servo navi. We can go through and take a look at the weight either in a chuck or on a table, pallet, things of that nature. Talk us through servo navi. What does that do for a customer? When or why would you use it?
So servo navi basically goes in and makes servo adjustments in the background, right, based on your work weight. So if you had a horizontal, for example, with an empty table or just a vise on it, right, it's pretty light. You could also load that up with a tombstone that has 4 vices on it and a bunch of heavy parts. Well, your acceleration deceleration only has one setting at a time, right? So if you have a lighter part, you can accelerate and decelerate a lot harder and still make the same accuracy part and save cycle time. Whereas if you have a heavy part, you might diff over sometimes or whatever if you're trying to accelerate super hard and then it's trying to stop all that weight and then make a direction change. So what servo navi does is it measures the work weight by running through a cycle. So basically some macros that are internal to the control, and then it measures that work weight and then adjusts those servo settings based on the weight of what's actually on the table right now. So a good example, if you started with, say, 1,000-pound part, and as you're milling this thing and machining material away, right, by the end of it, it may only be a 300-pound part. Well, if your servo settings are set for that 1,000-pound part, by the time you go to your finishing cycle, now you're giving up cycle time, right, because it's still accelerating softer and decelerating softer based on the initial work weight. So you can change your work weight setting on the fly in order to accommodate what weight you're cutting at the moment.
Yep.
Yeah, we had a customer recently that had a workpiece that was way out of balance, and they were having, as Chris said, the diff over issue, and they were running like 50% for the rapids. So we discussed the best way around. They wanted to change this, change that.
Let me pause there. So when you talk about the diff over alarm and a part being off balance, you're talking about what I'm picturing in my head. You've got a tombstone and you've got a heavy part hanging off center, basically off center line. So when that B axis swings, that inertia of that moment as that thing's swinging one way or the other, that's the part that you're trying to control, right?
Yes.
Through your acceleration, deceleration parameters.
Exactly.
Okay.
Yeah, so instead of changing the rapid rates for everything, we could tune it for that part. So the B axis was the one that was having an issue. The XY were fine, but their solution was to turn the rapids down.
Okay.
Cycle time went through the roof. Not a good solution. So we went through the process, and now they run it. And the work weight changed, I don't know, about 50, 60 kilos, so 100 pounds. And it was just enough, the way the part was shaped, that there was a moment that when it stopped, it would just drag it through where we wanted to stop it at.
Okay.
And again, servo nav we have for circles. And as the Japanese guys call it, the velvet hammer, where it takes the transition.
The velvet hammer.
Yeah, when you cut in a circle,
Yep,
you have the
changeover
transition.
quadrant.
So it changes the acceleration or the power as it's changing direction. So it goes from 6, 7 microns. I've seen it go down to 2. So the velvet hammer is something that we use to make round better.
Okay. Excellent. Very good. And that's something, if you tune a part, I think you said that you can save that, right? So if I'm setting it up for a specific part that's off balance or something like that, I call it up with the program every time. Is that something that can be, is that called through the part program as well? I think you had mentioned if you had a heavy part and you're going from a heavy hog out and you remove 1,000 pounds out of it.
The work weight, we can go back and forth as we do it.
Okay.
Or the rotary, they're the two that are initially you can set back to factory.
Okay.
The other two are sections where you have to change the program or the file that's in the machine. So it's something that we'd have to look into. But the work weight and the rotary, they're initially, you can initialize them back to factory.
Okay. Talk about advanced retract for the tool change. So if you are in the middle of a tool change and you hang up the tool changer, how do you work your way through recovering from that? Maybe you're in the middle of a tool change, power goes out, somebody e-stops it. 100 different variables could happen that hangs up something in a tool change. What are the steps that the OSP has built in where you can actually back out of that?
Absolutely. The OSP has a really nice function for recovering from tool change issues. So once you go into the machine operation page, right, there's a ATC button, and it has a single step forward and a single step reverse button. So basically an ATC cycle might be 30 steps, right? You don't ever see that. You just call T1M6 and people just know a tool change happens. But that actual cycle in the tool change macro has a bunch of different steps in it, right? So if you're not back to step 1, you can't do the next tool change. So in case of the power goes out or e-stop, somebody hits reset, something going on there, we can go in and just basically single step either forward or backward and just steps through each step in the ATC cycle until you get back to where you want to be. So it's super user friendly for recovering from a tool change problem.
About pallet changers, does that do the same for a APC?
Yeah, the same thing pretty much. It lifts up and goes around, so if it stops, and as Chris said, we have the button. You select the operation button, then you pick APC, and you have the ability to go forward or back. I like to go backwards to see why it stopped.
Yeah.
But that's just me.
Think of it like a cassette player on the 1988 IROC Z, right? You can forward and reverse it.
Yep.
Talk us through tool life monitoring. So I know that there's some third-party software that we use, some of our partner companies and things for specific applications, but the OSP control has its own tool load monitoring as well. I think I said tool life monitoring, but I meant tool load monitoring. Talk us through that. What are the applications where it's best suited for, and when would you look at what we do from an Okuma standpoint as standard versus when you actually make that step to a partner type product?
I mean, we've used the tool load monitor. Whenever we do I recommend, I should say, not we, when we do horizontals, we want to make sure that the product is safe. So when it's unmanned, the worst thing would happen to have it fail 5 minutes after you go home. So the load monitor for the machining centers is relatively simple. We have 5 or 6 variables that we can set. You can set the time that it's going to overload and the duration it can set at that time before it overloads. So like for drilling, when it spikes the spindle, when it starts cutting, we know the load's going to be 22%. If it gets to 25%, we can set it to be that sensitive that it kicks out immediately, or you let it fight its way through. Okay. Then it's tied to the tool life management where we can expire that tool, and the next time it uses it, it grabs the sister tool.
Okay.
But there's, like I said, 5 things, a G code. So it's relatively easy to use, and then you can expand on it as it goes forward. But from a simplistic, pretty easy to use.
Is there a limitation to the size of tool that you're using or the size of cut that you're doing?
Not really, because each tool is individually tuned, if you will, to its load. Right, so it's just looking at load. So whether it's a 1-inch tool or a 1 millimeter tool, all it knows is spindle load. So what it does at the beginning, it has a little bit of time where it ignores the load, because as you turn the spindle on, right, typically you have a large spike, in load. So it's got a little delay period where it knows that the spindle takes a second or a half a second or whatever to come up to speed. So it ignores the load for that period of time. And then once the spindle gets going, then it'll start looking at load again.
Okay.
Yeah, we could even do no load monitor. We're expecting a load and something happened to the tool or the part, you have 0 set wrong.
Okay.
So if it's cutting through the air.
So you're not in the cut, either the tool broke or the part's not where you thought it was.
So again, another way to prevent, an unpredictable situation. So we can at least have an idea of what happened.
All right. Same for tapping. We can do tap torque monitoring. So all along the same lines of making sure the tap's there, it's doing what it's supposed to be doing. All your stuff's protected that way.
Okay. So in terms of tapping, what about the tap retract function?
So the tap retract function, what that'll do for you, if you're tapping a hole and you happen to be at the bottom of the hole and the power goes out, or somebody hits e-stop or resets the program or something stupid that they shouldn't do, or just, act of nature or whatever, what the tap retract function does, it remembers what the pitch of the tap was and where you are in the process. So when you power it back up or recover your loss of power condition, you fire a G code and it will just back that tap straight out of the hole. So typically in the past, right, once the tap started in,
back it with the spindle rotation.
That's
right?
correct.
You're not just retract.
Exactly. Yeah, It's not a straight retract. It's that wouldn't do much good. So the way it used to have to happen, right, if that was the case, you'd have to take the part out of the vise with it still attached to the tap. You might have to loosen the collet if it's in a collet, right, and then back your spindle off manually, things like that. For machines that don't have to be at home, you could release the tool possibly and then walk the spindle back out of the way. So before tap retract type functions came along, that was the hard way. You had to get that tap out of the hole, or sometimes you just have to bust it.
Okay.
So this saves a lot of that stuff, especially for people that are prone to power outages, right? I grew up in Florida. 3 o'clock every day, the storms roll through, right? So, there's going to be thunder, there's going to be lightning, and 50% of the time there's going to be the power that flickers, and it's always going to happen at the worst case time, right? So when the tap's in the hole, that's when the power is going to go out.
Right.
So this it's a nice little feature to help you recover from that stuff.
Okay, excellent. So Ron, what out of all your years of experience running Okuma mills, what's your go-to? What do you think is the coolest function that you use day in, day out on an Okuma mill? I'm gonna ask you the same thing on the lathe. So get the wheels turning.
The coolest function. We have so many, and wow. The gauging that we have is nice. I use that primarily for all of our mills. We offer it now. Another thing is tool life management. For, again, going back to the unattended operations, it's easy to use. You group your tools together. You can do time or count. And once it's running, the tool expires after it's done. Next time it uses it, it grabs the next one in the group. You can set which one it uses first, so you don't have to use up each tool. It'll use the first one, expire it, and use the next one in the order you choose. So it's something that, with the automation we're providing now, you gotta protect yourself from you.
Right. And the days of having one operator stand at one machine all day long machining parts is long gone. You have to amortize that labor cost over many machines. So
absolutely, it's going to do the same thing over and over.
Yeah.
And once you set your processes up, and again, you have to have good processes. And this will help you have a good process, because when we use it initially, how many parts do you think you can get with your tap or your drill?
Right.
So you can set it to count down, analyze your results, keep going. Or that's the number, 200's the number.
Right.
So it helps you set it up and come up with a number, not a wild guess.
Okay, excellent. Chris, what about you? If you're looking at multis machines or a lathe, what's the stuff that you found over the years is most beneficial to you?
This is a tough one because there's a lot of things on the
lot,
list.
right?
So, from a setup guy perspective, we have a function that's called turret pulse handle. So what you can do is set a parameter, basically push the turret index button to release the turret, and now you can use the hand wheel to jog your turret around. So for anybody that's ever stuck a drill in, sticking out in an axial or a radial direction, rather, right, that's basically going to point at the back sheet metal when you spin this turret around. Sometimes you're kind of guessing a little bit how far that thing can stick out, and I've drugged many of them through sheet metal before, or broke the tool, where this allows you to check that clearance real easily. You know, sometimes you try and set that tool on the back side where the sheet metal is, so you know your tightest point. So that's a very good one. We have torque skip. So what torque skip does is...
That's a good one. I forget about myself.
I mean, I love torque skip. So if you're going to go transfer a part from one spindle to the other on a multi-spindle lathe, torque skip will actually measure the axis load of your sub-spindle, right? So when you're pushing up to grab the part, it makes sure it's seated correctly. So, you know, there's little variations in tolerances, things like that. So maybe if you cut your part 2,000 short on the main spindle side, now it's not seated correctly on your sub-spindle side. So there's all kinds of things that can go on. Well, torque skip just runs in there. You give it a in position window, basically. So if it doesn't see the part within this window, then it knows something bad happened. So stop there. But it basically will just run in and push up against the part until it sees the specified load, and then it knows it's there, right? So that it'll clamp.
So we used to do that for kind of a poor man's version of auto gauging. Instead of having a Raniszewski probe come in and fail safe, make sure the part's there, we'd bring up a dummy tool and press against the part. And you know, when operator loads part A, it should be at such a distance. And if it's not, flag the machine, let an operator come over and see what happened. Either put the wrong part in, called up the wrong program, whatever the case may be. But that's a standard function that, you know, again, until you brought it up, I wasn't even thinking about it.
I mean, you can use it to set zeros. You put your dummy tool in, run it up, use torque skip for the Z-axis, right, and touch up against the end of your stock, capture your actual position that you're sitting at the moment, and set your work zero with it. So it's the poor man's probe in the case of something like that.
Excellent.
You know, another one just to throw in the list that's more of an OSP function is mid-auto manual. So what mid-auto manual does, it works on lathes and mills, but you can stop anywhere in the process just by pushing feed hold. You can go into mid-auto manual, jog your tool away from your workpiece. So if you need to change an insert or inspect your drill or whatever, once you go back and hit sequence restart, it jumps right back to the position that you just left and picks up cutting again. So in the case of a turning cycle that maybe you've been running a roughing cycle for 20 minutes on this part, right, and the insert goes away, the last thing you want to do is stop and have to air cut all that stuff that you just did. So you can just jump into mid-auto manual, back out of the way, index your turret if you need to, change your insert, whatever you need to do, then jump right back into the process where you were, so you never lose a step.
Yeah, excellent. All right, guys, thanks again for your time today. Ron and Chris, you both brought up a lot of interesting points about the OSP control and some functions that I think a lot of times go unnoticed. So again, everybody listening, thank you for joining us for Shop Matters. I'm your host, Wade Anderson. If you have questions, comments, any ideas of things you want us to talk about, reach out to us at okuma.com/shopmatters. Till next time, thanks.